Hey guys, this is Victor here with Dapper Dash. I have a very special tutorial that I wanted to share with you today. It is a special time in the channel because we are almost at 500 subscribers and it's taken us just about under a year to get to this point. Today we're going to build a simple linear regression equation to try and predict the exact day that we can expect to hit 1,000 subscribers. I'm very excited to share this with you, so let's jump right in. Okay, so here's the data set that YouTube provides. It's just two columns. It is a date and the number of subscribers that I gained on that given day. And as you can see, my data goes from October 22nd. And in this particular case, we're going all the way through September 19th. So let's get this moved into Power BI. All right, so here we are in Power BI. And the first thing that I want to do is I'm going to go ahead and bring my data set in. And I can see everything looks good. Like I mentioned, it's just a date and the number of subscribers I gained on that day. So my data set is in here, and the very first thing I want to do is just visualize it real quick. So I'm just gonna create a line graph here, and we're gonna bring in the date on the axis, and we're gonna bring in the number of subscribers, and we'll change some of this to make it a little bit more visually appealing. I like to remove the title on the y-axis. I like to remove the title on the x-axis just because I already know what I'm looking at. And I can also get that information from the title. And so this is just going to be daily subscribers. Okay. So here's the timeline, like I mentioned, from October 22nd through September 19th. This is the timeline of how many subscribers I've gained on every single day. But in order to do the regression line, in order to predict when we're going to hit a certain number of total subscribers, I do need to understand the running total. And so that's the next part that I want to build out here, is the running total. I'm going to copy this graph, just bring it down here. And we're going to go right into a running total. So for the running total, this is needed for the regression line, like I mentioned. And this, if you don't know how to build a running total, I can show you real quick. So this I'm going to call time frame subscribers. My running total formula is going to be a calculate. The expression that we're going to evaluate is the sum of our subscribers. And then we got to add a filter. So the filter that we're going to add, we go here at filter, and we're going to add a filter on everything that has been selected from our subscribers table. And the part that we want to incorporate for the running total is we want to sum up all the subscribers from every day up until a certain point in time, or up until a specific date in our table. And so in order to do that, I'm going to put in the date. So we're going to do a filter where the date is less than or equal to the max and then the date again. I'm going to close that. I'm going to close my calculate function. So you don't have to worry too much about this. I'll copy this function into the description, and you can just replace it with your own date and your own values that you're needing to evaluate for the running total. I'm going to go ahead and hit enter, and I'm going to drop that one into this graph here. So here's our running total, our time frame subscribers. Same thing, I'm going to change it a little bit and change the title to maybe total subscribers. And for this one, I am going to bring in the data labels. So as you can see, as of this point, as of September 19th, I have a total of 503 subscribers. Okay, so how do I know that this is working? We can do a simple check. I can go ahead and bring in and add everything from this top graph here, and it should add up to 503. I mean, we could bring in, and there it is. Our total subscribers is equal to 503. The next thing that I want to do is I also want to add a slicer. And I want to add a date slicer. So I'm going to add it up here. I'm going to bring in the date. Yep, that's exactly how I wanted. I'm going to remove the slicer header. I am going to add a title, and it's just going to be called my date slicer. Date slicer. And so another check that I can do is this date slicer is going to filter both of these graphs to a specific time frame. And so this will tell me in this time frame there's a total of 388 subscribers. So my running total from the beginning of that time frame through the end should also equal that exact number. All right, as I move it around, 459, 459, 496, there's 496 in there. And so I know that this is working, 3. So my running total here is 3. It looks like on January 17th I gained 2, and then I gained 1 more on January 20th. So 2, 1 more, 3, and it's been 3 subscribers for the remainder of that timeline. Okay, so I know that now I know my running total is working. So the next step is to get ready to start building the regression line. Okay, so in order to solve for the regression line, I first want to take you back so that we understand what exactly a regression line is. And firstly, it's just a line. And if you remember from maybe high school, the equation of a line is just y equals mx plus b. Or written in this case, it's y equals a plus bx, where b is the slope of our line, x is our x variable, a is the intercept, and then y is going to be our predicted variable. Okay, so here the intercept is represented by this equation right here, and the slope is represented by this equation. Right, so these are the equations for our simple linear regression, and then all we have to do is plug in our x value, and we're able to determine what the predicted y value is going to be. And so what I've done is I've broken it down for you. Only 1, 2, 3, 4, there's only 5 pieces that we have to solve for. So 2 of the pieces we got to solve for is the sum of our y. In this case, in our data set, it's the sum of our subscribers. Okay, the next part is this blue piece. You can see it shows up 3 times. That's the sum of x squared. And then there's this green part here. It shows up 4 times. It's just the sum of our x variable. And then there's this orange piece, the sum of xy, which I have it represented here. And then the last piece is n, which this represents the number of rows or the number of observations. And so I have that here. And that's all that really goes into this equation. And so what I've done is I've translated the intercept here. You can see that it's the sum of y times the sum of x squared. So sum of y times sum of x squared minus the sum of x times the sum of x times y over n times sum of x squared minus the sum of x, and then we square that. And I've gone ahead and done the same thing for the slope. I've translated it super simple, and we're actually going to move this into Power BI, and we're going to start to solve for these variables. Okay, so here we are back in Power BI, and we're going to start our regression line. So I'm going to enter a new measure. I'm going to call this regression line. And the first thing that I'm going to do is I'm going to isolate just my x and my y variables. And in order to do that, I'm going to create like a little virtual table. I'm going to call it data. And this virtual table, I'm just going to select columns. So this is going to return a table. Selected columns from what table? Well, in this particular case, it's everything that is in my subscribers table. The next part is, well, what columns do I want to return? In this particular case, I'm going to name this my X values column. And my X values is going to be my date, subscribers date. And I'm going to go ahead and hit comma there. And then the next column that I want in this table is my Y values. And my Y values is just going to be, in this particular case, you don't want it to be subscribers because we're not predicting, how many new subscribers I'm going to have on a given date. We're trying to predict how many total subscribers we're going to have. So it's actually going to be our running total formula that we calculated. It's going to be our time frame subscribers. That's going to be our Y value, and we're going to go ahead and close this function. I put a link in the description to a blog that actually helped me a lot with the regression line. And what they have is they actually account for the possibility of maybe null or blank values in your X or your Y. I don't really have to worry about that because I know that all of my data points have values. But if for some reason you're getting an error or your line isn't working out, so try this out and it might help you. Either way, you'll get the same result. But in the blog, what they do is they actually add a filter to this table that we've solved for here. And they add a filter. And in their filter, they just say, apart from returning your X and your Y values, you also want to make sure that there's nothing that's blank. And so they write a not is blank. And then in this particular case, it's going to be your X values. So make sure my X values don't have a blank. And make sure my Y values don't have a blank. And then we're going to close our filter. So for me, this worked perfect. But if for some reason you run into any errors with just this piece, check to make sure that there aren't any blanks and add the entire filter. Either way, this will get the exact same result. Okay, so now that we have our table with just our X and our Y values, now we're going to solve for those variables from our linear regression equation. Just to show you that I'm going to copy this exactly the way that we calculated, I'm going to go ahead and copy this, and I'm going to copy all of this, and I'm going to bring it over into DAX. Okay, so this is going to be our variables to solve for. This variable here we're going to call our Y underscore sum. And Y underscore sum is just going to equal the sum of, and remember, we're grabbing it from our table that we created up here. Table, and it's going to be the sum of our Y values. Next variable, sum of X. So we're going to go var X underscore sum equals sum X. Remember, it's going to be data. And this is going to be our X values. Close parentheses. Sum of X squared. So I'm going to name this X2. And this particular one is going to be our sum X from our data. And it's going to be our X values squared. And then sum of X times Y. So var xy is going to equal sum X data X values times our Y values. And then the last one is the n, which if you remember the n, this is just the number of rows or the number of observations. So var row underscore count equals count the number of rows in our data table. Now I'm going to add solve for equations or formula. Let's see, solve for formula. So what we're going to do here is I'm going to title this var intercept. And we're going to go ahead and start replacing this with our variables up here. Same thing down here. Var slope is going to equal our equation that we brought over. So all of our Y sum is going to be here, the sum of Y, replace it. Sum of Y, we're going to replace it. Let's grab our X, sum of X, right there. This is our sum of X in here. Even though we're going to square the sum of X, it's not the same as the sum of X squared. So sum of X right here. Sum of X times Y right there. And okay, that's good. We're going to grab our X squared, which is the sum of X squared here. Sum of X squared right there. Sum of X squared Okay, the sum of our x times y, sum of x times y, sum of x times y, and then the last part is our row count, which is our n. Okay, regression. So var regression is going to equal, and I'm going to write SUMX here, and this is coming from our, now we're not in our data table anymore, we're going back to our subscribers table, and we're going to type in our formula. So it's going to equal our slope times our x value, and our x value is our date, right? mx plus b, so slope plus x plus, and then the intercept. And the intercept we've already solved for right there. And that's it. All we got to do now is return our regression. I'm going to go ahead and hit enter. Hopefully no errors. Oh, it looks like we forgot one row count right there. There we go. Hit enter, everything checks out. So now we're going to add our regression line into this graph here. All right, so we're going to go ahead and we're going to add the regression line into our graph. You can see it shows up there. I'm going to go ahead and change the color. Now, if you're wondering if this is really the regression line, you know, how can I verify that what we did actually worked? Well, if you go to this analytics tab here, you can add a trend line. And you can see that the trend line is the same equation as our regression line. I can change this maybe to silver, so you can see it right there. And you can trust that this is right, because as we move our data points around, right, our regression line changes, the trend line follows it perfectly. And if you're wondering, well, why do I need the regression line? Why don't I just rely on this trend line? The reason why is when you're trying to predict a number, you need to know the slope, because the slope of this line tells you how many new subscribers you gain every day. That's something that you can't get from the trend line. You need to actually get from the formula that we calculated in the regression line. So I'm going to go ahead, I'm going to remove the trend line. And now we're going to focus on calculating the slope so that we can get to predicting when we're going to hit that 1,000 subscriber mark. Okay, so for the slope, we're going to leverage our regression line. So I'm going to copy everything in here. We're going to go ahead and create a new measure. And we're going to call this a slope. And that's going to equal part of our function here. Now we're not going to return the regression, we're going to return the slope. And we really don't need this or even the intercept. We kind of just need the slope. I'm going to go ahead and hit enter. We're going to put in a new card for our slope. And we're going to bring the slope in, 1.79. Now remember, what the slope means is the number of new subscribers that we expect to gain as every day that goes on. So this is our average daily new subscribers. Now this number will change depending on the time frame that I'm looking at. Because obviously if you're looking at a time frame where your business was really booming, where it was really busy, well then this number is going to be a lot bigger, right? During this period of time, I was gaining a lot more subscribers than I was during this period of time. So we can look at that. If we focus down to May to June, we were earning almost 6 subscribers per day during this time frame, right? But if we only look at the last 30 days of the channel, we're only averaging about 1. So the slope will change depending on the period of time that you're looking at. Now that's going to be important when trying to determine when we're going to hit a certain number of subscribers. Okay, so let's go ahead and add the rest of the parts that we're going to need. What I'm going to do is I'm going to create a parameter, and this parameter is going to be a new what if parameter. Predicted subscribers, or actually subscriber goal. Let's do that. Subscriber goal. And we're going to start at, because we're already at 500, we're going to start at 550. and we're going to go to 1,000. So 1,000 is the number that we're going to get to. We're going to increment by 1, and let's just default this to 550. We're going to hit OK. And so here's our subscriber goal. Okay, so right now our goal is set to 550. So let's create another measure. Let's see how many subscribers we have to go. Because right now this is summing up the total number of subscribers, right? But this changes as we change the time frame, which we don't want to do that. The only reason we want to change this is to maybe use a different slope of the line, a different regression line. But we don't want to actually, just because we're using this regression line here, it doesn't mean that we have a total of 193 subscribers. No, this is just the number of subscribers that were gained during this time frame. So we actually need a measure that gives us just the total number of subscribers. So total subscribers. And remember, this has to ignore any filters as we change the slicer. So in order to do this, I'm going to create this SUMX. And I'm going to select all. So this ignores any filters. And we're going to go to our subscribers table. And what is it that we want to sum? Well, we want to sum the number of subscribers. So subscribers, and hit enter. So that's our total subscribers. So this right here is actually our time frame subscribers. But we need a number that is our total. We're going to drop that right there and bring in total subscribers. So 503, right? Now remember, that's the number that we don't want to change, because that's where we're starting from. We can change the slope depending on which model we want to use, maybe our more aggressive timeline, but the total subscribers can't change because that's where we're at today. All right, so now we can create another measure that tells us, well, how many subscribers do we have to go to get to our goal? So I'm going to name this subscribers to go. Subscribers to go. And this is going to equal our goal value. Yep, that's right. And we're going to subtract the total number of subscribers. Hit enter. I'm just going to copy this card here. Change this title. Subscribers to go. All right. So you can see here we have 47 subscribers to go in order to get to our goal of 550. If we change the goal to 1,000, we have 497 subscribers to get to 1,000. Okay, so that's working. And then now the last piece that we're going to have to add here. How many days is it going to take us to earn 47 subscribers if we're gaining an average of 1.79 subscribers per day? So that's the next calculation. So we're going to add another measure. And this is going to be days to go. Days, let's go days until goal. Okay. And for this one, we're going to take our subscribers to go. Right, so this is going to be our 47, and all we're going to do is we're going to divide that by the slope. We're going to go ahead and hit enter, and we're actually going to round this up, right? We don't want 1.2 days or 10.1 days. We just want, let's just round up to the next day. All right, and bring this into here. Same thing, let's just change this title real quick. Okay, and the title is Days Until Goal. And that's going to be our Days Until Goal. And for these, we don't really need the category. All right. So there you have it. If we're earning about 1.7 subscribers per day, and we have 47 subscribers to go to hit our goal, it's going to take us approximately 26 days to get to our goal. Now, it's useful to know how many days it's going to take us to get to our goal, but it'd actually be nice to have a date, right? To tell someone, hey, 125 days until you get to your goal is not the same as telling them, hey, by October 15th, we're going to expect to get 1,000 subscribers. So that's the next part that we're going to add. We're going to add a measure. And this measure we're going to title date of goal. And so we're actually going to calculate a date on this one. And the date that we're going to calculate is the most recent date on our data set. Now today for me is September 20th, but my data goes up until September 19th. And so I want to build this out till September 19th. I'm going to grab the year of today, and I'm going to grab the month of today as well, because I know I'm in September and today is September. And then the last part that you need to do is you need to enter a day. Now, like I mentioned, for me, it's September 19th. However, it's not just the 19th. I also have to add the number of days until I reach my goal. Days until goal. And so this is going to tell me the date of when I expect to hit my goal. I'm going to go ahead and hit enter. And I'm going to bring in another card. And here's my date of goal. We're going to actually make this a short date. And we're going to bring this in. Okay, so in 26 days, I will expect to hit my goal of 550. And that'll actually put me right at October 15th. So that's the day that I can expect to hit 550 subscribers. I'm going to change the background here a little bit. And we'll see that as we change, maybe we go during a more aggressive slope, right? We said May to June seems to be really aggressive. Let's go back. Let's see if we can get an even more aggressive slope. There we go. I want to make sure that you can see that this is calculating the date correctly. So at an average of almost 5 subscribers per day, and we have 47 subscribers to go, we're going to reach our goal of 550 in approximately 10 days. 10 days from today, which is the 19th on my data set, is September 29th. So that's how you can verify that that is changing. So, I mean, there you have it. You see that this is working, right? We can change the slope. Let's go back through all time. How long is it going to take us to hit 1,000 subscribers? It's going to take us approximately 277 days to hit almost 500 subscribers, right? To almost get to that 1,000. And we can expect to hit that goal on June 23rd of 2022. Now for my specific, the specific goal that I want, I think I'm going to start uploading again. I'm going to try to be active in my YouTube uploading. So I'm going to use a time frame somewhere between here and forward, because I expect I'm going to have some ups and then some down days where maybe I'm not as active, but I expect this to be my trend. So let's go with May 31st. I'm going to use May 31st as the day that I'm going to use this slope right here. So with this slope, I can expect to hit 1,000 subscribers on June 17th of next year. So, in the future, if you want to come back and look at this video and see if we've hit this number by June 17th, then we know that our regression line worked pretty well. So yeah, there you have it. This was the video. Now, if you want to stick around, there is one part that I want to show you. I did have someone ask me, they said, Victor, is it possible to have this regression line extend all the way out to some future date, right? Even though we only have data points for this time frame, is it possible to have the regression line show on the graph maybe out a whole year so that I can see what we expect to hit next month and the month after and then the month after that? And I did find a way to do that, and so I can show you that if you want to stick around, and we can go over that right now. Okay, so if you stuck around, I'm going to show you how we're going to go ahead and extend the regression line out so that you can see future projections on the graph, or at least some alternative that might help you out. Maybe not exactly quite that. So on this top graph here, I'm actually going to remove this for a sec. And what we need to do is we need to create a new table. And this is going to be a dimension table. So this is going to be a dim date. Okay, so we're going to write calendar. And the start date is going to be the smallest value from our subscriber's date. And then the rest of this is going to be how far out do you want your data to go. So I'm going to go to 2022, July. I'm just going to go July 1st. And that's going to create this dim date table here. Okay, and it's just going to have every date. So if we go look at it, it's just going to have every day from when our data set starts all the way through July 1st of 2022 or whatever date you designate. Okay, and I'm going to use that date here in this top graph. Okay, and the next thing that we're going to do is we're going to take our regression line and we're actually going to copy that over because we actually want to calculate using the same regression line. We want to calculate what the values are going to be on every day that's in our date dimension here. So I'm going to put a new measure and regression extend or something. I'm going to copy that over. Everything's going to be the same except for the very, very bottom part. We're not going to use our subscriber date as our X value anymore. We're actually going to use our dim date. So we're going to use the date from our dim date table. And that's going to be a date. And it's going to come from our dim date table. Go ahead and hit enter. And I'm going to bring in that regression model into our values here. And we're going to show our data labels. Just so you know that this is working and it matches what's up here. If we go to what's predicted for June 28th, the regression line says 310 subscribers, right, on June 28th. So let's go find June 28th. And do we have 310 subscribers? We do. So it matches 310 to 310. This is the same regression line. And let's make these a short date. But you might be wondering, well, I thought we were expecting to hit 1,000 subscribers by June 23rd. But according to the regression line, we're not expected to hit even 1,000 by July 1st. And that's just because this is an estimate, right? This is an estimate of where we're going to be. And obviously we have information that the regression line might not be aware of. The regression line on September 19th says that we should be around 460 subscribers, but we know that our actual number is about 503. So it's just an estimate. There's error, right? Okay. So can we add it to this graph down here? And the answer is we can. And now there's not going to be a solution that's perfect. What we can do is we can actually join these dates here. And if we go back on this graph here, we can actually add our extended regression line, and we can change our date axis to come from our dim date table. And now you'll see that the regression line all time, man, these values are pretty bad. None. There we go. You can see the regression line. Here is our actual value. It ends right on, I mentioned, September 19th. But then after that, you still have the regression line extended all the way out through whatever timeline you want. Now, one problem that you'll face here, though, is if you start slicing the data, well, then you're only going to limit it to this time frame here. Right? This isn't going to go all the way out to July 22nd anymore. So that's one of the issues that I encountered there. But if you have your data set and you know the exact data that you want to calculate the regression on, then you can extend this line all the way out. You just have to create this dimension table. You have to run the same regression on it, except for your X values are now going to be the dates from the dimension table. And then now you can use that regression line and couple it with your running total here, and you can see how the regression line extends out. Or you can have it on a separate graph out here. So either way works. If you have any questions, obviously let me know in the comments and I can try to help you out. But if you stuck around this long, I appreciate it. Thanks for the support. And for any subscribers that are trying to help me out get to that 1,000 mark, I appreciate it. Thank you. And yeah, we'll talk to you guys later.